Welcome to your weekly geometry recording. We are in week 8, and this is our first week in October. Please make sure you've got your math notebook out and you're ready to take good notes as you watch this recording. There's going to be some good stuff in here for you that will be helpful when you complete this week's assignments. As always, I'd like to start with a warm-up question that gets us thinking about what we did last week, and we're going to continue on with this theme this week. So last week we looked at how we can prove triangles are congruent. We learned 2 ways, 2 postulates. And if you need to review those, take a moment to do so. You can look in your notes. But I want you to look at these 2 triangles below. There's 2 triangles, and determine if you can prove that they're congruent using one of those postulates that we learned about last week. That's it. So take a moment. You could click pause, and then when you're ready to check your work with mine, go ahead and click play. So last week, we talked about 2 postulates that help us prove 2 triangles are congruent. And those were the side, 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 and the side, angle, side. So if they're looking at this triangle, we can look at the notation. Those ticks are going to be very helpful to us. So this leg's of this triangle is 1 tick. This leg of this triangle is 1 tick. So we know those legs have the same length. They're congruent. And then we see some more ticks. These legs, this leg here has 2 ticks. This leg also has 2 ticks. So we know those legs are congruent. And then our hypotenuse, really we don't even need ticks in there because it's a shared leg. And if a triangle shares the same leg, we know those legs have to be congruent. So we can prove those triangles are congruent by using the side, side, side. We have 3 sets of corresponding sides that are congruent. Therefore, those 2 triangles are in fact congruent. We can prove it by the side, side, side postulate. All right, so this week we're going to move on to Unit 2, Session 6, where we're going to add to our list of ways that we can prove triangles are congruent in addition to the side, 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 and side, angle, side postulates. You're going to take a Unit 2 quiz that covers Sessions 1 through 6, and you're also going to do a fun project where you're going to create a logo using triangles this week. So I just wanted to review a little bit about last week and then again add to our list of ways we can prove triangles are congruent. So remember last week we talked away that there's 6 facts that we need to have in order to show triangles are congruent. And those 6 facts are that we have to have all 3 sets of corresponding sides need to be congruent. So our corresponding side lengths need to all be congruent. So 3 sets of those. Same is true with the angles of our triangles. So to have congruent triangles, all your corresponding angles also have to be congruent as well. So remember, triangles, to be congruent, they have to have the same, all the corresponding sides have to be congruent as well as the angles. Same shape, same size. So 6 facts. All of our congruent side lengths, or all of our corresponding side lengths have to be congruent, and all of our corresponding angles have to be congruent. Wow, that's a lot. 6 things that we have to prove. Well, lucky for us, as I explained last week, we don't need to show all 6 facts are true. We've got some shortcuts. So there's certain combinations of the facts that are sufficient enough to prove that the triangles are congruent. That's such things as proving the side, 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 and side, angle, side. So these combinations of facts guarantee that if a triangle can be drawn with that information, it will take on only one shape. So only one unique triangle can be created, thus guaranteeing that the triangles created with this method are congruent. So that's where our postulates are going to come in handy and help us eliminate needing to prove that all 6 facts are true to prove that the triangles are congruent. So these are our shortcuts. Last week we learned side, 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 and side, angle, side, making sure that that angle is sandwiched between the two sides, just like over here. That angle is sandwiched between the two sets of congruent sides. Now, adding to our list this week, angle, side, angle, ASA, angle, side, angle. And now, sandwiched between two sets of congruent angles, you'll have a side. So order is important here. That side has to be sandwiched or included between those two angles in order for it to be angle, side, angle. Another one is angle, angle, side, angle, angle, side, angle, angle, side. So we have two sets of corresponding angles that are congruent and one set of one side. And notice the side is not sandwiched in between. It's the order angle, angle, side. And then last but not least is the HL, which is the hypotenuse leg. The hypotenuse leg postulate. So this one says if you have right triangles, if you've got two right triangles, if the hypotenuse and the leg of one right triangle are congruent to the corresponding hypotenuse and leg of another right triangle, then they're congruent. So note, you can only use the hypotenuse leg theorem for right triangles only. The other ones that we looked at up here do not need to be with right triangles. Only the hypotenuse leg one does. All right, so we talked about the side, 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 and side, angle, side. This one's new to us this week, the angle, side, angle. Angle, side, angle. Angle, side, angle. The corresponding angle, the sandwiched inside or included side, and then the corresponding angles. That makes it angle, side, angle. And next, we've got angle, angle, side. So see how this works? Angle, angle, side. Angle, angle, side. If two triangles have two sets of corresponding angles and then a side, we can also prove that the triangles are congruent. So these are the postulates that we've learned. We've got 4 of them, and we also have the hypotenuse leg, and we'll talk about that a little bit more in a second here. Remember, hypotenuse leg you can only use with right triangles. So the order of these matter. So what's important to look at this list, you see that there's no side-side angle. We can't use that postulate. Or if we flip it around, it's going to spell us a bad word. We can't use angle, side, side. So an easy way to remember is if you spell a bad word, that's not a postulate we can use to prove that two triangles are congruent. We can only use these ones up above, and the order is important. So let's look at some examples and see if we can apply these. So there's two different triangle examples. So let's start, we'll call this one number 1. And first of all, I want you to tell me if you can prove that these two triangles are congruent by one of the postulates we just learned. So some of these triangles, maybe we can't prove they're congruent. So what have we got here? We've got, look at our ticks. Our ticks are going to be helpful. We've got one leg here and one leg here with one tick in it. So we know that those legs are, corresponding legs are congruent. Then I see I've got an arc, one arc in our angle here and one here. So I know that that angle, those two angles are congruent. And then I've got one more set of congruent sides. They both have 2 ticks in it. So can we prove those two triangles are congruent using one of the postulates we just learned about? We can. And which one can we use? So we've got side, angle sandwiched between another side. So side, angle, side. So we can use side, angle, side to help us prove that those two triangles are congruent. Side, angle, side. What about, let's call this one number 2. Can we prove those two triangles are congruent? So take a moment and look at what's marked and decide if we can use one of our postulates to prove that those two triangles are congruent. Okay, so looking at number 2, I see that we've got a set of corresponding sides. We've got a set of corresponding angles and a set of corresponding angles. So what do we have here? Angle, angle, side, angle, angle, side. So we can prove that these two triangles are congruent using angle, angle, side. So yes, these are congruent, and we can prove they're congruent using angle, angle, side. So remember, order is important here. So you should have these 4 postulates written down in your notes now that you can use to prove two triangles are congruent. Let's look at one more. So can we prove these two triangles are congruent? Do we have enough information to prove that these two triangles are congruent using one of the postulates we just learned about? Side, 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 angle, side, angle, or angle, angle, side. Do we have enough information that we can use one of those postulates to prove that the two triangles below are congruent? So take a time and think about that. All right, so I see that there's a right angle here and a right angle here, so we know that those two angles, corresponding angles, are congruent. And then I'm also given one arc here and one arc here, so I know that those two angles are congruent. And then last but not least, we have a shared leg. We have a shared leg. Both those triangles share that leg, so we know that leg has to have the same length. There's nothing else on this triangle that we can assume. We can only use the ticks and those arcs. That's the only information that we know is congruent. So what do we have here? We've got two sets of angles and a side. So we can prove that this is congruent by using the angle, angle, side theorem. So we've got angle, angle, side. I'm going to go on to the next slide. One more to try. Can we prove that these two triangles are congruent with the information that's given? So take a moment and ask yourself, can you prove that these two triangles are congruent using the given information? All right, we've got this leg here has to be congruent with this leg because there's two ticks. We've got this leg here has one tick and this leg has one tick, so we know those are congruent. And then we've got one set of congruent angles. Do we have enough information to prove those two triangles are congruent? So what do we have? We've got an angle, a side, and a side. Uh-oh, we spelled that bad word, which is not one of the combinations that we can use to prove two triangles are congruent. So in this case, we cannot prove that those two triangles are congruent. We cannot prove that those two triangles are congruent. We don't have the right combination of our sides and angles to prove that the two triangles are congruent. All right, so we also talked about the hypotenuse leg theorem, where we can only use it with a right triangle. And as long as we have the hypotenuse and any leg, then we can prove that the two triangles are congruent. So that's only with right angles. That's only with right angle triangles. You can have a hypotenuse and a leg. So can we use the hypotenuse theorem to prove that the triangle ABD is congruent to triangle ACD? So do we have enough information to prove that this triangle ABD is congruent to triangle ACD? Do we have enough information? Well, look, they're both right angle triangles, so we can use the hypotenuse leg theorem. But do we have enough information even then? Well, there's this leg right here has got one tick, and this leg here's got one tick, so we know that those two legs are congruent. And then look, we've got a shared leg. This leg right here is shared. So we have the hypotenuse. Remember, the hypotenuse is always directly opposite of your right angle. And we also have a leg. So yes, we can prove that these two triangles are congruent using the hypotenuse leg theorem. We've got enough information. All right, that's a wrap. So let me put up your key phrase assignment. All right, so I got our key phrase assignment, the question down. We learned about several different new postulates to help us prove that two triangles are congruent this week. What type of triangles can you use the hypotenuse leg postulate with? So one of the postulates we learned about was the hypotenuse leg postulate. And what type of triangles can we use the hypotenuse postulate with? And that's it. So directions to complete the key phrase assignment are below for those of you who might need a reminder. Otherwise, once you complete, you're going to get your points for watching this recording. And as always, if you need any help as you're working through this week's assignments, let me know. Reach out for help. I'm here to help you guys out. Have a wonderful rest of your week.